So we're going to talk about the average rate of change. Now, the average rate of change is another word for slope. And how do you find slope? Well, hopefully you remember that slope is the letter M. I don't know why it's M, but it is. And M is a fraction. Slope is a fraction. And that fraction that you compare is your rise over your run. So when I talk about average rate of change, I'm talking about slope. I'm talking about your rise over run. It's kind of weird. Why do they call it slope? There's a reason. We'll talk about it. Now, but what we have here is I want to find the average rate of change on this interval, or the slope on this interval. So what I do is I find -2, which is right here, and I put a dot at it. Then I find -1, which is right here, and I put a dot there. So at -2 and at -1, do you see those dots right there? I put a dot at -2 and -1, and then I draw my slope line. To find the slope, I draw a line. Now, the question is, what's your rise over run? So now we got to do a rise over run, right triangle, for slope. And what you should notice is that's a rise of 4 and a run of 1. So don't you put rise over run, so isn't that going to be 4 over 1? And doesn't 4 over 1 reduce to 4? So the rate of change from -2, which is this coordinate, to -1, which is that coordinate, is a change of 4. Meaning, as I went over 1, then I go up 4. The rate of change is how is it changing as you take one step to the right. Now, let's go why are we calling it average rate of change and not slope? Well, you can't really find slope of this line. Isn't it ever changing? So if we called it slope, it's like that's not the slope. There's a whole bunch of slopes along this line. So we can't call it slope on curves. You have to call it average rate of change when you deal with curves. Now when I deal with a line, can you find the slope? Yeah. But with a curve, you have to find average rates of changes. So that's why you have the word different from slope. Average rates of change allows you to find a slope-looking thing for curves. So that's the reason. But anyways, so let's find the average rate of change or slope of -1 to 1. So -1's here, and 1 is up here. So 1 is right there. Well, this one, isn't the line, isn't that just a line for the slope? So let's draw our right triangle. So we have going up right here and over. Looks like I went up 4 and over 2. So we write, is that 2 over 4 or 4 over 2? It's rise over run, so isn't it 4 over 2? And can you reduce that? Which is 2, which is a slope. Which the average rate of change means, as I go over 1, didn't we go up 2? Don't we keep doing that? So slope, average rate of change, interchangeable there. But you had to call it average rate of change here. Last one, we're using this notation, 4 to 6. So can I go to 4, put a dot, and 6, put a dot. So 4, I put a dot, and 6, I put a dot. And then can you make a right triangle? That's 1 and 2. So is that 1 over 2 or 2 over 1? It's rise over run, so it's 1 over 2. But isn't this one going downhill? So when we go downhill, don't we put a negative on it to tell us we're dropping? So that negative is kind of important, okay, to remind us, oh, it's a drop of 1 over 2. And basically, that's how we do it. To find average rate of change, you find slope, but you find slope on whatever interval you have, because isn't the slope constantly changing depending on what interval you choose? And that's what makes a difference than just simple line slopes.